As I said, there will be a panel discussion, but there is our last speaker before the panel discussion coming now to us. Hello. So, Matthias Biniok. Okay, good, thank you. Matthias studied computer science and IT management in Jena, Tel Aviv and Frankfurt.
Yes.
And he is working for IBM, including a data center monitoring team and a development team at the IBM Research and Development Lab. I'm really curious what that all means with banking and sending a autonomously free-flying robot with AI power to the IBM Watson to the ISS.
Yeah, I will explain that in my presentation.
Thank you so much for being here, and the stage is yours.
Thank you. All right, hi everybody, my name is Matthias Biniok. I work for IBM Watson. Watson is kind of the artificial intelligence platform for IBM. And today I'm going to explain to you some real-world cases, real-world applications of artificial intelligence in various industries. But before I do that, I would like to start with a quick explanation about what we at IBM mean when we're talking about artificial intelligence or AI. So let's start with that. As you can see, AI is not really the new thing that is going to adapt to everything, covering everything. No, AI is more like a new connection, a new partnership between humans and machines. And actually, Ed spoke in his keynote exactly about the same thing, so sorry for repeating, but that's actually what it is. It's a new way of connecting machine and humans. And as you can see, humans excel at various things. For example, they're good at creativity, they're good at moral and compassion, for example, but machines, they can scale. Cognitive systems can understand language, can understand images, and can understand patterns to really solve existing problems. And when we combine these two skills, actually, the human skills and the AI skills, then we can create a new thing. And that's why at IBM we are not really talking about artificial intelligence. When we say AI, we are more like talking about augmented intelligence, augmenting the human senses, and that's what we're trying to do here. So I wanted to start with a nerdy joke. I hope that's okay with you. So when we're talking about AI or about coding in general, many top-level managers, for example, they understand, they use coding and algorithms to so the drones didn't crash into each other. So I know that's a nerdy joke, sorry for that. So they might imagine this comment, this kind of C++ code, if going to crash into each other, then just don't. And I think it's the same with AI. Many people say, I want to use AI in my company. Let's throw many documents at IBM Watson or at Microsoft's cognitive platform, and then something cool happens out of nothing. But this is not the case, actually. You need to train the systems to do specific things, and you need to train it for a specific use case. And some of these use cases I want to present to you, and those are real-world applications. All right, so let's start with trash. So we started to build a platform for a municipal customer, actually for a city, to recognize trash. Why are we doing this? Right now, a citizen in this city has his Clean app. So they have an app on their phone, and they can just use it to recognize trash. Right? Or before it was like that. They took a picture, and then they sent this picture to kind of the trash company, and they would look at the picture, would say, this is only some grass, some plants, not important. We're going to do that next week. And or maybe it's glass or a bottle, a broken bottle or something like that. That's something we need to pick up very soon, because otherwise somebody could hurt themselves. So what we actually did, we said, well, that's a very, very manual process, looking at pictures, very boring for the people. So we trained a system to actually recognize different types of trash. So what they're doing now, they're sending this picture to our IBM Watson platform, to the Watson Visual Recognition Service, and the service actually can say, okay, this is, for example, glass, and now I will automatically send a technician, a trash technician out there to pick it up, or yeah, if it's only plans or something, then it's not an issue, we can do that next week. So this kind of small innovations, automations are good starting points for companies to yeah, kind of get into artificial intelligence. Yeah, so here the garbage is automatically classified, and then it's going to be the responsible team is sent out. Okay, we have another case. Actually, we in our IBM booth we have a very cool Mercedes, so you can just come over and have a look at it. You can sit in it, and you can try out this cool app. We just implemented this app for Mercedes. It's called Ask Mercedes, and we integrated our Watson Assistant. That's kind of our chatbot or virtual assistant platform, and we trained it to understand kind of the handbook, kind of the instructions about your car. So what you actually can do, you can ask via voice or via text, how you like, how you wish. You can just ask the assistant, okay, how do I start my car? I hope all of you can start your car, but maybe there's a difficult problem, like how do I troubleshoot problems with my brakes or something like that. And the assistant app can actually assist you. But we also implemented another thing into this system with augmented reality. So we combined two techniques to actually create a better solution than before. So with this augmented reality, you can actually point at your car and say, okay, what's that? For example, the number 17, you click on it and then you get an explanation of what it actually is. So very simple use case actually, but if you use it and if you're a new car owner or you just hired a car, rented a car for example, then yeah, it will be very helpful for you. The next point is Woodside Energy. It's an Australian company, energy company. That's also an interesting case because they have many old people. They actually have very experienced project managers, very experienced engineers, and many more people, and also a broad documentations of different kinds of information. And what they wanted to do is actually they wanted to create a knowledge base that you can ask with natural language for any information. So you can just go to this knowledge base, to a website, or maybe even to a smartphone, and you can just ask, well, there is a lack in and this oil refinery or something like that, and did this happen before maybe? And actually the system searches in its huge document corpus, finds the right documents, sorts them by relevancy, and also finds the right passage within the document and presents it to you. So you can have actually a deep insight into your whole knowledge base, and all the experienced workers, which will be gone soon, have actually ingested their knowledge into the system. And that's what we did with Woodside Energy in this case. That's a German case even. So yeah, as you can see, the text is in German. It's Inter Insurance. It's an insurance company in Germany. Oh, and what they did, they wanted to sell dental insurance, and they wanted to sell it to younger people. They wanted to sell it in a fresh way, and that's why they approached IBM and told us, well, you have good experience with that. How can we do that? And we thought about, oh, maybe we can do it with a chatbot. But the chatbot should not only give information to you about your dental insurance, how it works, and so on. No, the chatbot should actually be able to even complete the full process, the end-to-end process. So you start with getting information about your dental insurance, and then in the end you have a complete contract, and you can say, all right, I signed this contract, I have now a new dental insurance. And that was what we did with Inter Insurance. And yeah, actually many other insurances and many other companies are using the same platform, the same service, the Watson Assistant service, exactly for these tasks. One more case, as you can see, I had to kind of blank out the name of the company. This is in the automotive case. It's a repair company. So you bring in your car, for example, your car has a damage, and then they will repair it. What you actually do here is you don't bring in your car anymore. You just take pictures of your car, and the damage will be classified automatically. It could work something like that. You have an app, and then you say, "Ah, damn, I have a scratch, for example. I would just take a picture of the scratch." Then the scratch will get classified automatically and will send into another neural network that will then calculate how much it costs to repair this scratch. And then, to have this end-to-end story, we implemented the process to even send a technician out to the car and repair it then on site. So you don't have to bring your car anymore to a station or something like that. You can just use this app and let it repair by himself, kind of. Okay, and now, so those were a few small examples, but I have one more and very important example because it's my personal project and I want to present it to you. It's the Project CIMON. CIMON stands for Crew Interactive Mobile Companion and was jointly developed by Airbus and IBM for the DLR, Deutsche Luft- und Raumfahrtzentrum. That's kind of the German space agency. And CIMON will be the first autonomously flying robot on the International Space Station. As you might know, Alexander Gerst, our German astronaut, has just went up to the space station and is going to stay there for 6 months, is also going to be the commander of this space station for a couple of time. And he won't be alone. He will have a new crew companion, a new crewmate called CIMON. You can see him in the upper right corner, actually. It's kind of a ball with a face. And CIMON should assist Alexander Gerst by his daily tasks and by his experiments. And CIMON is based on IBM Watson technology. So what we are doing there is we actually have a free-flying companion that could fly in zero gravity right next to the astronaut, and you can talk to him and ask him for specific instructions. You can ask him specific things. Let me give you an example within an experiment. So imagine you're an astronaut and you have to do a crystallization experiment, very complex one. And normally you have a procedure with 50 pages, 100 pages. It's on a laptop. It's in a PDF format, and you have to open the laptop, have to open the procedure, and then look at it and see, okay, I need to do this and that. All right, I will float to my experiment station, have a look at the experiment station. I do a little bit of stuff, and then I forgot what to do next. I forgot what to, what's the next step, actually. So I float back to my laptop, have a look at the laptop, I remember, and go back. And that's the current version of how they do it right now. And that's not really, that's really time consuming. And time is the most expensive stuff on the International Space Station. It's extremely expensive. So what we try to do is actually to reduce the time effort for the astronauts. So what they're doing now is CIMON is flying in the upper right corner maybe, and the astronaut will just say, "CIMON, come here." CIMON has a microphone array on top of his head and actually can do direction of arrival. So he kind of hears where the sound was coming from and then says, the sound is coming from there. Then he will do object detection, finding a human shape, finding a face, and then also recognizing the face. What kind of astronaut is it? Is it Alexander Gerst, for example? And then he knows, Alexander Gerst just caught me. I will just come quickly up to him, and then he will float autonomously. This was built by Airbus, by the way, autonomously to the astronaut, and then on his way he will just say, "Hi Alex, how are you doing? By the way, there's an experiment on your agenda. Let's start with the crystallization experiment." And then they do the crystallization experiment together. CIMON is floating right next to him, giving him instructions, and he can ask, okay, well, what's the next step now? Or he can even ask, what kind of tool do I need to use right now in this step? or even very complex questions like, why do I need to use Teflon right now and not any other material? And we trained Simon with this kind of knowledge base to answer those kind of questions and even more. Of course, we trained him also on small talk, and he can play some music, all the Alexa stuff as well. So he can do that as well. And yeah, but his main task is actually to support the astronauts by their daily tasks. One more remark, because I think it's really cool. All the services are coming from the IBM cloud in Frankfurt. We actually have an internet connection from the International Space Station via a NASA satellite to a so-called ground station, from the ground station to the IBM cloud in Frankfurt and all the way back up. In the beginning, when I built the first prototype, there was like an 8-second latency. So it took 8 seconds. I just talked to Simon and I said, Simon, how are you doing? And he was like, sorry, I didn't understand. And of course, you don't want to have this kind of experience for the astronauts. That's why we implemented a cool way of reducing the latency. Actually, I'm not allowed to talk about it because I'm filing a patent for it right now. But what we did, we reduced the latency from 8 seconds to now 2 seconds. And for the International Space Station, this is a great step because they have this physical latency, which is there via this NASA satellite of almost 500 milliseconds. So 1 second round trip from Earth to space and the other way around, and 1 second for the for the speech to text and the recognition and also the visual recognition on ground. All right, I don't know about the time, but I think that's it so far. If you have any questions, we can discuss it now or later if you want to. Thank you. And one more remark, Simon is actually at my IBM booth in the Pavilion 34, so he's there as kind of ball, so you can have a look at him and yeah, I can explain you more about it.
Okay, Matthias, I invite you to stay with me on stage. Yep. There are people helping us with, well, getting everybody else here and getting some chairs, and then we can go right into the panel discussion. Well, maybe as long as we're waiting, does anybody have questions for Matthias now? You may speak now. Maybe something. There's one question. Can I have a microphone there, Anna or Roman? The lady in the red top. There you go.
Thanks a lot. Very interesting talk about Simon. Was he able to, or is he able to also creatively give instructions? Because we know that in experimentation, nothing goes as by the book. And if he's reading from the book, there must be some creativity. Is that also AI-based from Watson, or is that left for the astronaut?
No, right now we didn't implement any natural language generation, for example. Right now we have a way how to kind of dynamically extract information from various documents and then kind of get it into the right format for Simon to speak and for Simon to show maybe some things on the display. We actually thought about this, but Simon is only a so-called technology demonstrator, and he is going to assist Alexander Gerst in 3 experiments in the beginning, and if that works out well, then hopefully we can also continue implementing cool stuff like other things like you said, for example.
So Simon is the perfect assistant, or you don't have to bring anybody else who's not an astronaut to the ISS.
Exactly. That's the idea.
That's already helping us to get into the panel discussion where we talk about AI journey, destination, or vehicle. I think that could be a vehicle, just Simon. Like, what is this from your perspective?
I think so. At least Simon is not a one-shot project. So Simon is actually made on the same or built on the same base technology that all the other cases I showed, for example, the inter-insurance or the dental insurance thing, or Ask Mercedes, it's the same technology. So it could definitely a vehicle for driving further progress in AI, especially in applying AI, because what we're doing here is a little bit of research, but not that much research as Ed actually has shown. It's more like applying existing services and applying existing AI components to a real world case.
Yeah, thank you.